x square minus x minus 2 is a factor of x cubed plus 3x squared plus ax plus b. You want to calculate the values of a and b and then write all the factors of the given expression. This looks like it's going to be a rather long sum, so let's get started. We've been given the value of f of x, which is x cubed plus 3x squared plus ax plus b, right? We've been told that x squared minus x minus 2 is the factor. Now, if you notice, generally we've given a linear expression as a factor. This time, the expression given to us as a factor is a quadratic. So let's split that further, right? So if I say x squared minus x minus 2, that if I split the middle term here, this becomes x squared minus 2x plus x minus 2. Right? What I'm doing is I'm factorizing this given quadratic polynomial. So that becomes this, which between the first two terms you can see there's x common, so x minus 2, and between the third and fourth there's plus 1 common and x minus 2. So so the factors here turn out to be x minus 2 and x plus 1, right? So therefore x squared minus x minus 2 is equal to x minus 2 and x plus 1. And why did I do all of that, right? Because if they tell me that x squared minus x minus 2 is a factor of my polynomial, right, f of x, that actually implies that the factors of this polynomial will also be factors of f of x, which implies that x minus 2, right, and x plus 1, which are factors of x squared minus x minus 2, are factors of f of x. I hope that makes sense. I mean, if this quadratic polynomial is a factor of this cubic polynomial, then the factors of this quadratic polynomial will also be factors of this cubic polynomial here. And we needed that. We needed that because we are going to use the factor theorem for each of these two factors now and frame two equations in a and b and solve it that way, right? So if I'm considering x minus 2 first, right? So if I'm considering x minus 2 first, I'll start by saying let x minus 2 equal to 0, right? That basically implies that x is equal to 2, right? And since I know x minus 2 is a factor, right, I can say that the remainder, therefore my remainder in this case, which would be equal to f of, well, you guessed it, 2, right, that should be equal to 0 by factor theorem, right? So let's do that. Let's find the value of f of 2. And for that purpose, let's substitute 2 in f of x. So I have 2 cube plus 3 into 2 square plus a into 2 plus b equal to 0. Right, let's simplify this a little. What do I get now? 2 cube is 8, plus 3 into 2 squared is 12, plus 2a plus b equal to 0. And if I rearrange this equation, I get 2a plus b equal to minus 20. Let this be my first equation. Alright, this is just my first equation where I consider the first factor, x minus 2. Now we need to do the same thing again. This time we'll be considering the second factor, which is x plus 1. So let's just do it. Let's just split our the place into 2 so that you can see the parallels here. First we consider let x minus 2 be equal to 0. Here we will consider let x plus 1 equal to 0. This gives me the value of x as minus 1. And again, since we are dividing it by f of x, and we know it's a factor, we can say that the remainder, right, which is equal to our f of 2, or rather f of 1 this time, f of minus 1, right, is equal to 0 because it's a factor, right? So f of minus 1, let's figure out the value of f of minus 1. It's going to be minus 1. Let me just see what's the expression. Yes, so we have minus 1 cube plus 3 into minus 1 square plus a into minus 1 plus b equal to 0. Alright, if I am to simplify this now, I should get another equation in a and b, and that's the whole idea. That's what I want. So minus 1 cube is minus 1, 3 into minus 1 square is plus 3, a into minus 1 is minus a, and I have a plus b over here equal to 0. Rearranging, simplifying this equation, I have a minus b equal to 2. Right, let this be my second equation. Right, so I have two linear equations in a and b, two unknowns, two equations, easy to solve. I'll solve them by adding, right? Equation number 1 and equation number 2. So what do I get when I add the two? So equation number 1 is 2a plus b equal to minus 20. Equation number 2 is a minus b equal to 2, right? And if I am to add the two equations, what do we get? 2a plus a makes it 3a plus b minus b get cancelled out. Minus 20 plus 2 makes it minus 18. Okay, so I'm finally getting the value. I can say 3a is equal to minus 18, which implies that a is equal to minus 6, right? Minus 18 upon 3 is minus 6. So if I have that value down, I can find the value of b by substituting a is equal to minus 6 in, let's see, equation number 2, right? So equation number 2, if I substitute, so it's a minus b is equal to 2, so minus 6 minus b is equal to 2. This is my second equation, and if I rearrange the terms here, I should get the value of b as minus 8, right? So here I've done it. I found the values of a and b, but that's not all in the question. If you read the full question, they have first asked us to find the value of a and b, calculate the values of a and b, and then write all the factors of the given expression. Okay, so we found two factors already, x minus 2 and x plus 1. Okay, we've already found two factors, as you guys can see, and x minus 2 and x plus 1. We want to find the third factor as well. We have two options for that, or rather three options. We can divide our entire polynomial with a and b substituted, of course, with x minus 2, or we can divide by x plus 1, or we can actually directly divide it by x squared minus x minus 2. I suggest we do it by the third way. Okay, so first let's just rewrite our f of x in this case. So I can say therefore f of x is equal to, with all the a's and b's substituted in there, let me just read the expression, x cubed plus 3x squared plus ax plus b. So x cubed plus 3x squared plus ax will make it minus 6x plus b makes it minus 8. Let me just reconfirm I've written the right thing. X squared, x cubed plus 3x squared plus ax plus b. Right. Okay, so this is our f of x, and we will divide it by the original factor that they had given us, x squared minus x minus 2. So let's perform division here. X squared minus x minus 2 is our divisor, and x cubed plus 3x squared minus 6x minus 8 is our dividend, right? So if I am to divide these two terms, again, basics are the same. First, ensure that they are in the reducing powers of x on both the divisor and the dividend, which we have, x square x and no x, x cube x square x and no x, right? Then we move on by dividing the highest powers. So x cube upon x square will give me x, right? X cube upon x square will give me x. And what you do is you multiply the quotient by the entire divisor. So if I do that, x into x squared makes it x cubed, x into minus x makes it minus x squared, x into minus 2 makes it minus 2x, right? I'm going to subtract the two expressions. Plus becomes minus, minus becomes plus, minus becomes plus, right? So subtraction, plus x cubed minus x cubed is cancelled, plus 3x squared plus x squared makes it plus 4x squared, minus 6x plus 2x will make it minus 4x, and we have a minus 8 down, right? Again, dividing the highest powers, we have 4x squared divided by x squared. So 4x squared upon x squared is nothing but plus 4. Okay, so now multiplying the quotient with the divisor, 4 into x squared is plus 4x squared, 4 into minus x is minus 4x, plus 4 into minus 2 is minus 8. And subtracting the two expressions, plus becomes minus, minus becomes plus, minus becomes plus. And so if you notice here, plus 4x squared, minus 4x squared cancelled, minus 4x plus 4x cancelled, minus 8 and plus 8 is also cancelled. So the divisor is, sorry, the remainder is 0, as expected. So we can actually divide a cubic polynomial and a quadratic as well directly if we like, and simplifies our job. So therefore I can finally say x cubed plus 3x squared minus 6x minus 8, right, is equal to my divisor, which is x squared minus x minus 2, into my quotient, which is x plus 4. And if I had to completely factorize it, don't forget the quadratic polynomial, for which we've already found the factors for, is x minus 2, x plus 1, and x plus 4. So these are my three factors for my given polynomial f of x. So x cubed plus 3x squared minus 6x minus 8. Right. So if I had to write my final answer statement now, remember we had to find the values of a and b, which we did. We found the value of a as minus 6. So my final answer statement here, so I know a is equal to minus 6. I did that. Then I found the value of b, which was minus 8. So b is equal to minus 8. And I had to factorize the polynomial completely. So my polynomial f of x in the factored form is basically x minus 2, x plus 1, and x plus 4. This here is my final answer. The values of a and b and the completely factored polynomial.